I'm going to talk about the concept of slope and its many representations in mathematics when we're dealing with lines. So the first one I want to talk about is slope as the steepness of a line, which we also often refer to as rise over run, basically when we're looking at a graph. So if I were to draw a line here, let's say, it doesn't really matter where I start, something that looks like this. So if I drew a line like this, connected my dots. To find the slope of this line, or the steepness of the line, it's a measure of steepness, what I could do is I can look at the rise over run from one even point to the next. So it doesn't matter which points we take. I could take these two here, and I could go, you could see that to get from one point to the other, I have to go up 2 and over 1. Okay, if we're going up in these directions, it would be positive. If we're going in these directions, down and to the left, it's negative. Okay, so you can see that from this point up 2 and over 1, that would give me a slope with a rise of 2 and a run of 1, which would be a slope of 2. Okay, so our slope there would be 2. Now, it doesn't really matter which points you pick. You could pick, this point and this point, for example, and you can see from here to here, we're rising 4, and from here to here, we're running 2. And you can see that rising 4 and running 2, if you were to actually reduce that fraction, gives you the exact same answer that we had before. Now, if I had a comparative slope, like a smaller number than 2, let's say a slope of 1/3, and I wanted to look at what this slope looked like, and I'm just going to pick a random starting point. There'll be a lot more with that when we get to slope-intercept form. This is just a brief introduction. But if I were looking at the rise over run of these points, that would be going up 1 and over 3. So if we looked at a line that had a slope of 1/3, it would look something like this. And notice that if you were jogging up this hill and you were trying to go as fast as you could, or maybe biking up the hill, this green line would be a lot easier to bike up or run up than this red line here. That's because it has the slope is not as high as this one. Now, negative numbers are kind of the opposite. When you have a slope, -8 actually is technically a smaller value than -3, but -8 is going to be a lot steeper than -3 will. Okay, so big negative numbers, or numbers that are further away from 0, will be steeper lines than numbers that are very close to 0 in terms of the slope. But let me now get into how to find the slope between 2 points, which is usually something that teachers make their students do in an introductory slope lesson. The formula for this is finding the difference in the y-coordinates over the difference in the x-coordinates, which the difference in the y's is basically your rise, and the difference in the x's is basically your run. Okay. Now the way we can do this using algebra is, let's just fill in. We'll do x1, y1. We'll consider that our first point, and we'll do x2, y2 to find the slope between these 2 points. Okay. We'll start off by subtracting y2 minus y1 like we have up here in the formula. So y2 is 5, y1 is 3, and if we subtract those two things, we'll end up with the difference in the y's. Now here we'll do 7 x2 minus x1, and 5 minus 3 gives me 2, over 7 minus 5, which is 2, and that again will reduce to 1, so our slope in this case, the variable we use to represent that being m, our slope is equal to 1. Let's try another one. We're going to take the difference in the y's, so we'll do x1, y1, x2, y2. We'll take the difference in the y's, which will be 4 minus -5, which we'll talk about in a second. So we're subtracting the y's, and now we need to subtract the x's after that. That would be -2 minus 3. Now from here, if I'm subtracting a negative, you should know from like a pre-algebra class or something like that, that this will cancel the negative signs and actually give you a 9. -2 minus 3 gives you a bigger negative, or a more negative number, which would be 9 over -5. So our slope here, or m, is equal to, we can't reduce that fraction, -9/5. And that would be our answer for this one. So the key being, again, we've got to subtract the x's and the y's, Got to subtract the x's and the y's to find your slope. Now this one, if we subtract 8 minus 8 on top, this one I put up here to show you the difference between two different types of examples. I'm just going to go right to switching the sign. So 3 minus negative 2, anytime that second number, that should just change to a plus if you have that second number as a negative. So 3 minus negative 2 should just be 3 plus 2. And then if we evaluate here, 8 minus 8 is 0. And on the bottom we get 5. And 0 divided by 5 is just 0. So in this case, we have a slope of 0, which we'll talk about what that is in a little bit. Okay. All right, we got a few more to go here. I know I'm going through these a little quicker. The x-intercept of 5 and a y-intercept of 4. We could also find the slope between these as well. What a helpful thing to do for this would be to write these as ordered pairs. So remember that an x-intercept always has a coordinate in for an x and a 0 in for the y, whereas a y-intercept will always have a 0 in for the x, and your number will go in for the y. So 5, 0 is the x-intercept, and 0, 4 is the y-intercept, and now from here we can just use our y2 minus y1 formula up here. I'm going to subtract the y's, that'll give me 4 minus 0 on top, and on the bottom, we'll get 0 minus 5, which is going to be 4 over negative 5, okay, which will be a slope of negative 4/5. Now, you could actually think about this using a graph too, and I haven't talked about negative slope yet, but so I won't go into that in too much detail. But if you thought about, okay, if I had an x-intercept out here at 5 and a y-intercept up here at 4, you can actually see that the rise here, since we're rising downwards, that's going down 4 and over 5, which is why this graph has a slope of negative 4/5. All these ways of thinking about slope, the rise over run is negative 4/5. All these ways of thinking about slope are interconnected. Okay, we'll keep going here. Next, we'll look at this last example. It's going to be a little bit like the one I did in green over here, but also a little bit different. Again, we're going to subtract the y coordinates, negative 3 plus 4, because that minus negative will change that 4 to a plus. And on the bottom, we'll have 10 minus 10. Now, if we combine these, this will give me a 1 over 0. And now this is actually very different than this example that we just did over here a little bit ago. The problem here is that the 0 is on the bottom. And if you punch this in your calculator, 1 divided by 0, you're going to get some sort of error that says cannot divide by 0 or undefined or something like that. And what we're going to write here when this happens is that this slope is undefined. Okay, you cannot divide by 0. This slope is undefined. Another way you could represent this is no slope. Okay, either of those answers is acceptable. So here your slope is undefined or you have no slope. And I'm going to show you a picture of what each of these things look like. Okay, so just as a rule of thumb, this will help you when you get into graphing different lines here. We'll look at positive. We're going to look at negative. We're going to look at a slope of 0. So slope, or m equals 0. And we're also going to look at an undefined slope. Or no slope, again, would be the other way to say that, no slope. Okay. Now, a positive slope, if you look at this like you read a book from left to right, go in this direction, so from left to right, a positive slope will always go uphill. Okay, from left to right. So if you think about, let's say, if you ever played the first Mario or Sonic the Hedgehog game, Mario and Sonic can only go in this direction. You can't go backwards. Okay, once you've moved past a certain point, you can't run backwards to that point. So if you think about Mario or Sonic here, if they are running uphill, it's a positive slope. Now, over here, if Mario or Sonic is running downhill, it's a negative slope. So from left to right, like you read a book, if your line is going downhill, that's a negative slope. Now a slope of 0, a little bit different. We've actually talked about these before though. These are horizontal lines, the ones that look like the horizon, like if you had like y equals in this case that'd be 1, 2, 3, 4, they have a slope of 0. So lines that have just a y or are horizontal have a slope of 0. Notice that the steepness is 0. It's not steep at all. It's like skiing on a flat open plane. Whereas here you're going up the ski lift with positive slope, and with negative slope you're skiing down the hill. Now undefined is a very unfortunate place to find yourself if you're skiing. An undefined slope is actually a vertical line. So if you are skiing off of an undefined slope, you are actually falling off a cliff here, and that would be no good. So if this is you falling, you're falling down to your death here, which is not a good thing. So undefined, again, undefined and no slope are when you have a vertical line. And again, these are lines like, let's count this, 1, 2, 3, same spot. X equals 4 would be an example of a line with an undefined slope. Okay, so those are all the different types of slope, and again, those will help you when we graph. The big ones to remember that'll help you catch little mistakes when you're graphing are positive and negative slopes. You got one more to look at. We'll look at the rate of change in a word problem. Tom bought a number of guppies at the fish store and observed their population over a number of weeks. After 14 weeks, there were 30 fish in the tank. After 17 weeks, there were 36 fish in the tank. Find the rate of change in the fish population. Okay, and what they mean by rate of change, all they mean when they say that is that rate of change is just your slope. They want you to use, in this case, your y2 minus y1 formula. Sorry, this thing's hard to write on here. Y2 minus y1 formula is equal to x2 minus x1. So we're going to have to somehow take the information in the problem and write it out as ordered pairs. And if we can do that, then we should be able to solve this problem. Now, the tricky part is going to be deciding which variable, is it the weeks or the fish, that represent x and y. And we said earlier in a previous video that x changes y, or the independent variable is x and the dependent variable is y. This is how we tell which variable is going to be x and which variable is going to be y. So if we look at the two things that are changing here, we have the weeks and the fish. So you have to ask yourself here, are the weeks changing the fish in the tank, or are the fish in the tank changing the weeks? And the only one that really made sense there was that weeks must be changing the number of fish in the tank. So we know that x represents a number of fish, a number of weeks, and y represents a number of fish. So we go back here, we'll look at the first ordered pair that they give us. 14 weeks, we said weeks is x, is the same as having 30 fish. So we'll put that in for y. Over here, we have 17 weeks is the same as having 36 fish. And now we're all set up to go. This really just becomes a problem we were doing earlier. So we'll subtract the y's first. So we'll do 36 y2 minus y1 over x2 minus x1. And if we subtract these, we should get 6 over 3. And that will reduce to 2. So now from here, we probably shouldn't leave this as just 6 over 3. We should probably maybe talk about what the meaning of that 2 is. And again, if you think about what the top number meant, top number was your y. That is a number of fish. And the bottom number is a number of weeks. Okay? So if we were thinking about what this meant in terms of a rate of change, this would mean that the fish are increasing, since the slope is positive, at a rate of 2 fish. If we write this as a fraction, it would be over 1. So 2 fish per 1 week. So the fish are increasing at a rate of 2 fish per week. Or again, if you wrote that as a fraction, you would see 2 is 2 over 1, 2 fish per 1 week. And that's the meaning of the rate of change in this example. So different ways of talking about slope. We had rise over run when we're looking at a graph, or the steepness of a line. When we're talking about ordered pairs, we had finding the slope between the 2 points using our slope formula up here. We also talked about the different types of slope: positive, negative, slope of 0, and undefined. And then finally, we talked about how to apply this to a word problem, and that rate of change is the exact same thing as the slope. So when you're looking for the slope in a linear word problem, the rate of change is the exact same thing as the slope.